In this video, we're going to be talking about the nomenclature of alkanes and cycloalkanes. So, the system that we use for systematically naming organic compounds is called the IUPAC system. IUPAC stands for the International Union of Pure and Applied Chemistry. And so, some of the keys that go into naming organic compounds is we need to identify the longest carbon chain. We need to figure out what the substituents are, essentially the branches coming off that parent chain, and then we need to give the location of those substituents. So, one of the most important aspects of naming alkanes and cycloalkanes is identifying the longest chain in a molecule. So, it's sort of the longest sequence of carbon atoms where we don't have to backtrack. And so, in this compound, I think the longest chain that we can find is 1, 2, 3, 4, 5, 6, 7, 8, 9. There's no other sort of single pathway that gets me a larger number of carbon atoms. Now, sometimes there may be more than one possible chain that's the same length. And so, to break that tie, we want to choose the chain that has the most number of substituents. So, the most number of things coming off the chain. So, in this particular molecule, I think there are two ways that we can have 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7. Right? The one that has the most substituents, right? So this one has 3 branches coming off. This one has 2 branches coming off. So we want to choose the parent chain that has the most substituents. So we're going to go with this one as being our parent chain. Now, the names that we give to the parent chain depend on how many carbon atoms there are. And so we have different prefixes that correspond to the different numbers of carbon atoms. So if our longest chain is 1 carbon atom long, then the prefix is meth, and the name of the parent chain is methane. If we have a 5 carbon chain, then the prefix is pent, and the name of the parent chain is pentane. If we have 10 carbon atoms in our parent chain, then the prefix is dec, and the name of that parent chain is decane. And so we have some larger ones over here on the right. You need to have the 1 through 10 prefixes memorized because we're going to encounter those a lot. Now, I think we've seen some examples this semester where the carbons actually form a cyclic chain. We name these similarly, except for a straight chain with 3 carbons would be propane. If we have a cyclic 3 chains, then it's cyclopropane, or 4 would be cyclobutane, or 5 would be cyclopentane. So let's do some quick practice. So we want to identify the longest chain in each of the following compounds. So on the first one, we could go 1, 2, 3, 4, 5, or we could go 1, 2, 3, 4, 5, 6. So 6 is obviously bigger than 5. So the parent chain here would be hexane. In this case, I can go 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6, 7, or 1, 2, 3, 4, 5, 6. Right, so I had 2 sevens. I can go 1, 2, 3, 4, 5, 6, 7. That has 3 substituents, or I can go 1, 2, 3, 4, 5, 6, 7. That has 1, 2 substituents. So I want to go with the one that has more substituents. So I like the 1, 2, 3, 4, 5, 6, 7 with 3 substituents. In this case, my longest chain is cyclic, and so I have 1, 2, 3, 4, 5. So that would be cyclopentane. Now, once we've identified the longest chain, we need to name the substituents or the branches coming off the chain. So the parent chain gets the ending ane, the branches get the suffix yl. So if I look at this branch, it's 2 carbons, right? So if that was a parent chain, it would be ethane. But if it's a branch or a substituent, then it's ethyl, right? One, two, three, right? The prefix is prop, and so that's propyl. A one carbon chain is meth because it's not the parent, it's a substituent, it's methyl. All right. Now, for our cyclic chains, whether it's the parent or the substituent depends on which is bigger, right? So if the cyclic is bigger than the branch, the straight chain branch, then the cyclic is the parent, and so this would be propyl cyclohexane, right? In this case, I have 3 carbons in the ring, I have 4 carbons in the parent, and so the straight chain gets to be the parent, and so that's butane, and then this is a branch, and so it's cyclopropyl. We'll talk about the one here in just a second. So once we've identified the parent chain and we have the names of each of the substituents, we need to specify where on the parent chain the substituents are coming off of. So in this case, our parent chain is 5, 1, 2, 3, 4, 5, and then we have a methyl coming off of carbon 2, and so this is 2-methylpentane. Right? This is a different compound because the methyl group is coming off a different carbon from the parent chain, and so this is 3-methylpentane. Now, it's important to number the parent chain correctly, right? So in principle, we could start numbering from this end or from this end. And so this could either be 2-methylheptane or 6-methylheptane. But we always want the first substituent to have the lowest number possible. So the correct naming would be starting from this end where we get 2-methylpentane. The incorrect naming would be starting from this end where we get a higher number for that first substituent. So here's another example. If I have multiple substituents, the first substituent should have the lowest number. It doesn't matter what all the rest do. So in this case, right, if I start numbering from this end, the first substituent is a 1. If I start numbering from this end, the first substituent is a 3. So the first substituent rules. So we should start numbering from this end. So the correct naming would be starting from this end. Now, in this case, there's a tie for the first substituent, right? Whether I start numbering from this end, the first substituent is a 2. If I start numbering from this end, the first substituent is a 2. So then we go to the next substituent. And so in this case, right, I can have a 2, 3 versus if I start numbering from this end, I would have a 2, 5. So 2, 3 beats 2, 5. So this would be the correct numbering. It may just happen, as in this example, that there's no tiebreaker based on the positions, right? Whether I go start from this end, this would be 1 bromo, 5 chloro, or 1 chloro, 5 bromo. So the numbers can't differentiate between these two compounds. In these instances, we go alphabetically. And so because bromo comes before chloro, we should start numbering from this end. The same rules apply for cyclohexanes. So if I start numbering from this one, I would have 1, 1, 3. If I start numbering from this end, I have 1, 3, 3, right? And so in either case, the first substituent is 1, but the second substituent in the left-hand case is also a 1 versus a 3 in the right-hand case. So the correct numbering would be what we see on the left. So to assemble the complete name, the parent chain comes at the end. And before the parent chain, we put the number and name of each substituent that comes off the parent chain in alphabetical order. If we have multiple identical substituents, so we have multiple methyls or multiple ethyls, then we use prefixes di, tri, tetra, penta, right, indicating that there's 2, 3, 4, or 5 of those substituents. but we don't include the di, tri, etc. when we alphabetize. So in summary, we need to identify the parent chain. We need to identify and name the substituents. We need to number the parent chain and assign a number to each of the substituents. And then when we put it all together, we put the parent chain at the end, and then we put the substituents in alphabetical order, along with their numbers. So if we were going to name this compound, the first thing we need to do is determine the parent chain. So I think I can go 1, 2, 3, 4, 5, 6, or 1, 2, 3, 4, 5, 6, 7. I think the 7 is the best we can do. So the parent chain is going to be heptane, and that'll go at the end. And then I have two substituents, and I can either number it as 1, 2, 3, 4, or 1, 2, 3, 4, 5. Right, we want the first substituent to be as low as possible, so I should start numbering from this end. So it's 1, 2, 3, 4, 5, 6, 7. And so the methyls are at positions 3 and 4. So this would be 3,4 dimethyl heptane. Now, there may be some instances where the branches are more complex than just a straight chain. So to name these, we start with the longest chain within the substituent. And so in this case, it would be 1, 2, 3, 4, and so it would be butyl. Then we name and number each of the groups coming off of the substituent. And so in this case, I have a methyl group coming off of carbon 2. And so the name of this substituent is 2-methylbutyl. Now, the naming can get pretty complex. And I think you'll see the problems in the textbook. They tend to not combine the complex branches with naming of the whole alkane. And so they typically just ask you to name the individual branches. And so while things can get fairly complex, the questions that the book asks and the questions I'll ask on quizzes and exams try to keep things more simple. Now, there are some branches of the smaller branches that appear very frequently, and so they have common names. And so I think it's important to be familiar with at least the 3 and 4 carbon branches and their common names. So a 3-carbon group would be a propyl, and if it's a straight chain, then the name of that substituent is just propyl. If instead of connecting on one of the ends of the 3 carbons, we connect on the center, then this group is called isopropyl. Or the name that we would give it from the complex branching would be, right, if I start with this as 1, the longest chain it can be is 2, so it would be an ethyl, and so the complex branch name would be 1-methylethyl. But this appears so frequently that you need to be familiar with the isopropyl name. The other common names that you should know are with 4 carbons in the substituent. If they're all in a straight chain, then that's simply just a butyl group. If it so happens that the carbon is attached in this way to the parent chain, this is called sec-butyl or secondary butyl, indicating there are 2 carbons coming off of the carbon that is attached to the parent. Right, and similarly, tert-butyl, right, the carbons attached to the parent, there are 3 carbons coming off, right? So 3 tertiary, so this is tert-butyl, this is sec-butyl for secondary butyl, and then isobutyl, it would be in this case. And then you can see the common name, or I'm sorry, you can see the IUPAC names for these branches that you see down below. But I think for both the 3 carbon groups, you need to know what propyl and isopropyl are. And then for the butyl groups, you need to know what butyl, sec-butyl, isobutyl, and tert-butyl are. So here's another example. So the first thing we need to do is find the longest carbon chain. So I think I can go 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. I think the best I can do is the 9. So 1, 2, 3, 4, 5, 6, 7, 8, 9 is my base chain. and then I have these substituents coming off. So I have a methyl, and from our previous discussion, right, this is a 3-carbon group, but it's attached on the center carbon, so this is isopropyl. So when I name these, the isopropyl comes before the methyls, so this would be, when I think about the numbering, right, I can go 1, 2, 3, or 1, 2, 3. So the first substituent is the same, but if I go to the next substituent, right, this would be 1, 2, 3, 4, or 1, 2, 3, 4, 5, 6. So I should start numbering from this end. So the isopropyl comes first, and it's 1, 2, 3, 4. So it's 4 isopropyl, and then 1, 2, 3, 4, 5, 6, 7. So it's 4 isopropyl, 3, 7 dimethyl nonane.